Metals make music, and different metals make different sounds. This is due to the different size and shape of the instruments, and to the resonance values of the metals themselves. To bend, coil, and shape the instruments, manufacturers need to understand how metals behave. Musical instruments may not have changed much, but modern manufacturers modify designs using computer-aided design, or CAD. This allows them to produce exact specifications for the individual components so that everything fits together perfectly. Yellow brass, red brass, nickel silver, stainless steel. These are the raw materials of musical instrument manufacture, the input. In the workshop, these raw materials are customised. Pipes are cut into lengths and drawn on a bench, which adjusts length, thickness and diameter. Processing begins. Chain drawing quickly and easily adjusts pipe dimensions, but for more critical tolerances, a mandrel is inserted into the tube, which keeps it a constant width and diameter. Hydraulic oil is used for lubrication and cooling. This pipe will be the slider on a trombone. Have you ever wondered why brass instruments are coiled? Because otherwise, you'd never be able to reach the keys. But bending tubes is trickier than you think. First, they dimple them in a press, and then bend them in a vise. Then they blow out the crimp on a blowing press. This pumps hydraulic fluid into the pipe at great pressure. The result is a perfectly curved pipe. So why don't they just bend the pipes? A Cnc drill is used to machine parts to very fine tolerances. In this case, part of a valve group. This is made of stainless steel because dissimilar metals slide more easily against each other. Why is this important for moving parts? Dennis uses a template to cut a sheet of red brass to make the bell for a trombone. Red brass is used for bell making because its high copper content gives good tonal quality. Once he's cut the sheets, he hammers them into a rough bell shape or breaks them in. Then he cuts teeth into the edges to make the seam, and he hammers these over, adding spelter, a mixture of brass, silver and flux, along the seam. Silver is used to help it flow. He uses a welding torch to fire the seam. The bell end is shaped on a CNC lathe. This quickly and accurately shapes the bell and cuts away any surplus metal. These bell ends are joined onto the rest of the bell and the seams hammered and finished. When the bells and pipes are made, they still have to be buffed and polished before assembly. Brass instruments need to look shiny. Everything must be polished, but some parts are too small to be done by hand. This is where everything finally comes together. Pipes, valves, slides and stops are all assembled into trumpets, trombones, horns and euphoniums. Precision is essential. The combination of poisonous solutions and electricity mean that care must be taken when electroplating. Many of the instruments are silver-plated, but first they're given a coat of copper, because silver bonds better to copper than it does to brass. Hugh's job is to check the instruments at the end of the line. Do they look right? And most important, do they sound right? He checks tonal values with a stroboscope and by ear. And once they're found to be perfect, the instruments are ready to perform.